Hello and welcome to the joint Splunk and TechStream webinar on how to operationalize your observability strategy. First, we're going to do a quick introduction of all the speakers today. Then we'll walk through how observability helps you find the unknown unknowns, how to fill the gaps in your enterprise monitoring strategy. We'll also present a customer success story and then walk you through how we can make you successful with our proven methodology. I'm Matthew Clemens, the Managing Director of the Operational Intelligence team at TechStream. With us, we have Chris Riley. Chris.
Hi, everybody. Thanks, Matthew. And thanks, everybody at TechStream for having me. My name is Chris Riley, and I am a senior technology advocate at Splunk. And I focus largely on how tech-enabled enterprises embrace DevOps and SRE and observability practices.
And hi, guys. My name is Carl Siepel. I'm a Senior Director of Operational Intelligence with TechStream. And my team is responsible for delivering on Splunk implementation projects, including observability solutions.
Great. And thanks, Chris, for joining us. We're super happy to have you. And we will hand it off to you to begin the journey in this webinar on observability.
Yeah, thank you again, everybody at TechStream for having me on to talk about this topic. And like most conversations you face in the tech field that's related to transformation, you kind of have to start out and make sure everybody's on a level set to know what are we actually talking about. And when we say the term observability, you may even see it abbreviated O11Y. And if you're one of the cool kids out there, you'll call it OLLY. This term is not necessarily a new term in terms of the problems we're trying to solve. But the reason we use this term observability, which comes from the world of manufacturing and networking, is so that we can adequately describe the new challenges we face with modern applications. Because modern applications, their complexity and their velocity really change how we manage them. And if you can't see the data and if you can't see the information in these systems, then you can't expect to operate and manage it. So what does that actually mean, that things are different? Of course, things are different. Things are always changing, right? I mean, that's kind of the impression that, technology is all about change. Yes, this is true. But where we traditionally had this approach where our customer actually was the server. It was that one server data center of servers that you set and you forget. And you usually probably had a server in that data center that had a name to it. And the reason you name that server is because once every 2 weeks, that server would get a disk full error. And you would go and restart it and everything's good. Now, there were applications running on this server, and there certainly were workloads and users consuming data from the server, but they were largely static. So you would deploy code to a server that's already configured and set up, and you wouldn't touch it. And you'd probably do that, maybe once a month on a fast basis. Well, the world of Agile came to us, and this idea of microservices came to us. So what happened? Well, that server went away. You no longer have a static server that you can always reference and you know where your code is running on. You are deploying small components of your applications to many servers, and those servers are ephemeral. They can live and die in some application in minute times, especially in the world of microservices. They're distributed. The relationship between one service to another service is largely unknown. So even me as the creator of a microservice, I don't necessarily know who's consuming data from it or where that data is going to. So it is not possible for an operator in this type of environment to hold in their brains, their minds, a conceptual image of the architecture and the relationship between all of these components. That alone changes the landscape. It means that you can't just start with the log. You can't just go to events. You need the platform to surface information to you. And in addition to the architecture and the infrastructure of the application, the relationship between services is changing. And where we used to just monitor the business logic, the APM information from each individual service, now we have to be concerned about the relationship between the services, their connectivity time. What you see on the screen right now is an example of a service map. This is how applications are starting to look. And if you have 5 or more services in your organization, it becomes nearly impossible to trace down issues. So those are the infrastructure and the architectural challenges with modern applications. But most enterprises find themselves in a state where they're not just cloud native or they're not just monolithic. They are in a transformation period where they are some blend of all of the above. And for some organizations, they will always be there. And so the other thing I'd like you to consider from a strategic standpoint is that visibility during transformation is absolutely critical. How do you measure the success of transformation if you don't do that? I'm sure you've all been a part of a project that has taken 6 months to a year, and by the time you finish the project, the outcome was already dated. You can't have the same happen in digital transformation. So as a part of this journey, your challenges around monitoring are also a part of it. And I'll give you an example more specifically. There's this process called the strangler pattern. The strangler pattern is where you slowly break off pieces of heritage infrastructure and applications and modernize them. You cannot embrace the strangler pattern without having a monitoring strategy that allows you to observe all of those components. So by now, I hope you agree with me that when we talk about monitoring modern workloads in the cloud and applications, we are talking about a different problem space, one that's faster pace, one that change frequency is high, and it's very, very distributed. So how do you address this? Well, many would argue that observability is just another term for monitoring, and I'm one of those. The reason we use this term observability is because heritage applications still benefit from being monitored in the way that we're used to doing it, but cloud native applications are not. And so this term allows us to talk about a new set of challenges. And the challenges are that the data needs to be surfaced to you. It's a push versus a pull mechanism. The platform needs to tell you where the issues are, and you do discovery into the log. Whereas in traditional monitoring, you get the event and you start at the log. And really, another way to look at this is, when do you decide to embrace the practice of observability? It's not for everything. You should absolutely consider, especially in hybrid environments, to pick the best monitoring approach for the infrastructure and the assets that you are managing. So observability first starts with the data, as all monitoring problems start. Now, in traditional monitoring, the data was typically the logs, and maybe you established metrics as well. In modern applications, we add 2 new data sets, traces and spans. Traces are the thread that go from the moment a user enters your application to the moment that user leaves the application. The span is the amount of time the user spends in each service and the order that that transaction hits those services. This is the glue that binds everything together, so that if your API gateway, for example, is what shows an alert, but the actual problem is in a specific microservice in your backend, you know to go and spend your discovery effort in the backend, not the API gateway. Second, observability also touches your development and deployment strategy. For example, in observability, we are considering a lot the application layer, which means we need to instrument at the application layer. Is that done with agents? Is that done by the developers with code? Or do you use auto instrumentation libraries to do that? It also is tied to your deployment strategy. Failure in an environment where you have canary releases or blue-green deploys is different than failure where you're deploying once a month or once every 2 weeks. And so all of these considerations come together. You've probably heard this term shift left. We're also talking about visibility shifting left as well. It is an approach to monitoring your applications. It is monitoring. It's just a different way of looking at your monitoring with a new set of technical capabilities. And it is a new collection of tooling that supports this added complexity. So whereas you might be just focused on a logging tool, you're now going to look at a new collection of tools support observability across your application. Here's when you should start to consider observability as a practice. As your infrastructure and code boundaries blur. So what I mean by that is we no longer have that data center that I was talking about before in those specific servers we always reference. We have configuration that is scripted. We have infrastructure as code. We have Kubernetes. We have microservices. And the boundaries between the code, the configuration, and the infrastructure is blurring. Now we ship artifacts that are containers, not just jar files for Java applications. So as those boundaries blur, you need to consider a practice of observability. When logs and metrics are not going to cut it, usually in distributed applications. When applications are increasingly distributed, and as components of the application become stateless and ephemeral. The extreme example of this is a serverless function. Serverless functions live and die in second time. By the time you have to support a serverless function, something that went wrong in a serverless function, that function itself or that instance of the function may have already vanished. So how do you make sure that you discover and troubleshoot that particular instance? It's observability practice that helps you do that. So now we know what observability is broadly. I mean, you definitely get a sense over time, and there's differences in opinion on the definition, no doubt. Let's talk about the dimensions and how they kind of come together in a solution. So the dimensions of observability is this. First, the data that you're going to get in. Second is full stack, making sure that your coverage of monitoring and observability encompasses your entire stack. And finally is the practice, the strategies that you build. So the data that you get into your monitoring platform is directly what determines the success of the output. I mean, garbage in, garbage out. I'm sure you've heard that. Some of the things to consider around the data is that we at Splunk truly believe in this approach of open telemetry. Open telemetry is an open source instrumentation and agent for collecting data into your observability tools. It democratizes how you collect data, and it makes it so that your agents and your instrumentation are not the determining factor for your observability practice. You also need to make sure you get the right data. So you're going to have logs that are going to be the source of traces and spans, and you're going to build metrics around those to have a better understanding of what's going on in your system. And traces and spans are the new data type that all applications would need to be instrumented with. We're also talking about data resolution, making sure that you have the context and the depth in the data that you are going to use to troubleshoot. For that, you're going to look at cardinality. Cardinality is the amount of metadata that comes with every trace and span. And fidelity is the amount of sampling or not that you do. In the case of like real user monitoring, you don't want to sample. You need all of the data. So you're going to look at getting a solution that has full fidelity. Once we're sure that we have all the data, we have the ability to correlate and get monitoring at each layer of the tech stack, even from the software delivery chain all the way up to our SIEM and all the layers in between with infrastructure, APM, and real user monitoring. So how does this come together with Splunk? And how do we look at observability as a practice? So some people might consider observability just to be traces and spans. At Splunk, we talk about observability as a suite, and it is called the Splunk Observability Cloud. From the infrastructure on the way up through your stack, we start with Splunk Infrastructure Monitoring. Then we talk about Splunk APM, Application Performance Monitoring, to get the unknown unknowns out of your application and surface this information and help you navigate distributed systems. Then we have real user monitoring for going all the way up to the top of the stack to where your application and the transactions touch individual users. And finally, once you've used this information to discover an incident, you get to the log. And the log is where you're going to get the code level information about where to troubleshoot an issue. Now, that's not all of it. That is the visualization, the discovery, the alerting. But you also need a strategy of incident response. And that's where Splunk on Call comes in to mobilize the right people at the right place at the right time. So looking at this from a suite and a cloud perspective brings all this tooling together to support a practice of observability, not just point solutions and visibility silos that you find in most organizations. And it's all powered by some really intelligent technology, machine learning, and a standardization around open telemetry to get the data in. Now I want to quickly show you some screenshots of the application in action. So first is Splunk Infrastructure Monitoring for real-time visualization of what's going on. In this particular case, you see a Kubernetes cluster, their individual pods, and a quick glance of what's going on in that infrastructure. It can be on-prem, it can be hybrid, and it can be multi-cloud. Our platform has pre-built dashboards. The integration for getting this data is seamless, and it's all based on the services and cloud infrastructure you're using. We also have Splunk APM, which goes one layer up into your application layer and business logic. This is where we will automatically build service maps, tell you the relationship between the services and where you're starting to see errors. So in the screenshot, you're going to see the red dots represent errors. The size of that dot represents the frequency of the errors. We also see latency between services. So this is all, again, real-time, full fidelity, and it correlates across all your services in your environment, no matter what stack they are running on. So you can have different tech stacks for each service. All of this wires together into Splunk on Call for the most efficient way to mobilize the right person at the right place with the right context, to reduce the mean time to recovery and resolve, and also avoid issues like a lot of organizations implementing spray and pray type strategy where they just blast it out to everybody, which causes burnout and may not get to the right people. There's also machine learning technology here for helping you find the right responder based on historical previous incidents. Once we have analyzed an incident and we need to get into the details, and you want to avoid this swivel chair approach of monitoring where you're just switching from one screen to the other screen, we now have the brand new capability of Log Observer, where you can deep dive into the logs directly from an event inside of APM or infrastructure monitoring, and it brings it all together to give you full fidelity of information. Now, these have always been kind of part of Splunk's core offerings, but we are deliberately investing in making sure that we have monitoring at every layer of the tech stack, not just to the business logic in your application. So that is why we are bringing in new technologies around real user monitoring, so we can look exactly what's happening at the user's level, their experience, because it's not just about being down anymore. Latency impacts your customers. So we are focused squarely on the customer with real user monitoring and this technology of synthetics, where we can test transactions and have a really good understanding and confidence in our users' experience and how the service is affecting them. In addition to that, the power of data allows us to give recommendations on how to optimize around best practices to improve your application, because it's not just about the firefight. It's also about resolving and improving the quality of your applications over a long period of time. That is what the practice of SRE is all about, not just firefighting. So the Splunk Observability Cloud comes together in a unified interface, and it integrates directly and seamlessly with your cloud provider. If you are a customer on AWS Cloud, we have direct integration into those cloud services so that we can deliver the value and the capabilities across all of these tools and help you troubleshoot them in a very holistic way versus doing point solution troubleshooting or swivel chair monitoring to accomplish the same problem. And so now I'm going to hand it off to Carl to talk about a real world scenario where these technologies come together.
Well, thank you, Chris. I want to walk you through an example of a customer success story that we recently implemented here at TechStream. A little bit of background about the customer. Well, I can't divulge their name. They are a leading fintech lending provider. And if you're not familiar with that technology, basically what they do is receive loan applications, primarily from a series of online brokers. So most popular one I'm familiar with is LendingTree. You go out to this brokerage site, the LendingTree brokerage site, you fill in your information, you say, I want, a car loan, a mortgage loan, whatever it might be, put in some information about yourself, and then LendingTree fires off that request to a multitude of providers that it has contracts with. And each of those providers then analyze the application, the information that you've submitted on the application, decide your credit worthiness, whether it's in line with the various programs that they offer and their various guidelines on who to allow loans to and things like that. And then they come back with either an offer that says, yes, we'd like to give you a loan for that $50,000 to buy that new car, and here's the interest rate that we'd be able to offer. Or they might decline if you don't meet the particular standards of their programs. And you might imagine that under the covers, there's a lot of things that go on just to make that happen in what, in many cases could be just a few seconds or maybe even just a few minutes of elapsed time in all of those handoffs between those online brokers and the loan providers themselves and other systems that those loan providers rely upon. In this particular case, this fintech provider, it has to go and make real-time calls back to multiple credit bureaus to take the information that you submitted and look and see how creditworthy are you. What's your credit score, for example, and other criteria that they might use in the process. So instead of having humans doing this, with paper and pencil and mailing things back and forth or faxing stuff back and forth like used to happen 5 or 10 years ago, this is now all being done online in basically real time with computers doing most of the work based on algorithms that each of these providers might program in. So let's talk about the pain points that they were having. As you've probably already surmised, there's a lot of different APIs that are involved here. There's APIs that the online brokers are using to call into these various lenders. And there's various APIs that the lenders are using both internally to handle the application process and the scoring process and the rating process, and ultimately the response back to the broker, but also to external third-party providers. As I mentioned, credit bureaus being one of the more obvious ones. So there's a lot of information that's flowing around through a lot of different APIs in very, very quick manner. Again, that could happen just over a period of a number of seconds. In this particular case with this fintech customer, they had parts of their application were on-prem in their own data center, And they had even parts of theirs in multiple cloud solutions, so AWS and Google Cloud Platform being two of those. In addition, as I mentioned, there were third-party systems that they interfaced with, and who knows where those were residing. One of their biggest pain points was whenever there was an outage in any of this flow of APIs, if you will, those outages are significantly costly to them. The numbers that we got from them was between $200,000 and $300,000 an hour in lost revenue when they were not able to respond in a quick manner to these online brokers. So you can imagine that if you're competing for that customer's business, the end user, the borrower in this case, if they get a response back very quickly from a lender that looks like an attractive rate, you might respond back 10 minutes later. By then, they may have already said, "No, I'm going with lender number one," and so you could lose that business. And of course, if you can't respond at all or can't respond in a timely manner, then you don't even have a seat at the table. So very, very expensive to them in terms of lost revenue. And what was challenging to them was that when they would have outages of the APIs, many times they would find out when their customers started complaining. So they didn't have effective monitoring of their internal systems as well as external systems that they were calling. And so they wouldn't find out until somebody actually called to say, "Hey, I was trying to apply for a loan and I kept getting this error message," and et cetera, et cetera. And so you can imagine how long of a period of time might occur before someone actually picked up the phone and called or sent an email or a text or something, even if that person even knew who to call. And so that was a very, very big challenge for them, was the time to recognizing when there was a problem. Because until they knew there was a problem, they obviously couldn't start to fix the problem. And because of the complexity of all of the multiple APIs, both internal and external, it just made it almost impossible for them to monitor with traditional tools. And as Chris mentioned, with ephemeral services and serverless functions and things like that, many times these things come and go so quickly that by the time their traditional monitoring tools even knew about a new service or a new server or a new serverless function, it was gone. Or they would at least miss the first 5, 10, 15 minutes worth of alerts and logs from that particular service when it got spun up. This also made it very, very hard for them to drive to a root cause. When they did find out about a problem, which again could take longer than desired, they then would spend a lot of time trying to figure out what was wrong. Is it our code? Is it the third-party service that we're calling? Is it the online service that's calling us, maybe passing bad data or something along those lines? And so again, all of these moving parts and the complexity of having this microservice architecture really made it hard for them to narrow it down to where the particular problem was and ultimately be able to fix it, because that's their desire, is to get the systems back up and running and start making money again. So what did we do for them? We took an approach, and I'm going to walk through the generic approach here in just a few minutes, but we sat down with a customer and we worked through what their goals and desires were. We talked through those pain points and where they were today and what wasn't working for them. Again, I'll go through a little bit more of that in a few minutes. And ultimately, we ended up implementing 3 pieces of the Splunk Observability Cloud solution with them. We implemented the Splunk infrastructure monitoring, sometimes you hear it called Inframon, the Splunk APM solution, and we also implemented Splunk Enterprise. Although technically, I guess that's not part of the Observability Cloud solution, it's still part of the portfolio. So we implemented all 3 of those solutions across their internal application landscape. Now, could we implement those on the third-party vendors? No, we couldn't do that. Could we implement those on the brokerage services, the online brokers that were sending the calls to this particular customer? No, of course we couldn't do that. We don't own those systems. The customer had no access to that. So, but we focused on their systems, and we'll talk a little bit about what we were able to do for some of those other ones. So with the Splunk infrastructure monitoring, we installed the agents on their application servers and their Kubernetes clusters. And that, almost within minutes of installing the agents, we started to get real-time metrics from those various systems, traditional CPU, memory, disk space, things like that. And again, across their Kubernetes cluster that they had, that you can see had over 130 containers residing on those. We then used the OpenTelemetry, or OTel, sometimes you hear it called that, the OTel collector, as part of the Splunk APM solution, installed that, and in this case, we did auto instrumentation, which is a process of installing basically libraries that wrapper the existing code that the customer has in some additional functionality that captures information about individual function calls and reports that back to the Splunk APM solution. And those are the spans and traces that Chris referred to earlier. So using that OTel collector, we used auto instrumentation. And again, very quickly, we're able to start to get the span and trace data from their custom code. We did work with them a little bit to show them how they could manually instrument some of their more critical pieces of code to provide additional information. So this is kind of one of those cases where, you know, the amount of work you put into it is pretty much commensurate with the amount of value you're going to get out of it. We can put the auto instrumentation code in place very quickly, and you're going to get a baseline of information out of that. But if there's certain areas that you want to get a little bit more detail or a little bit more granular or add some additional information along the way, we can easily do the manual instrumentation for those particular things and not have to instrument all of it manually. We can use the automatic for most of it and then use the manual method for the small stuff that makes sense. Then the third piece of this was, again, Splunk Enterprise. We installed that hosted up in AWS for them to gather the application logs from their different systems on their servers and across those clusters. We then worked with them to set up what in Splunk is called detectors, basically just alerts, where we identified what are some of the key things that they want to know about when they happen. And this can be traditional, monitoring type stuff like disk space, CPU, memory usage, things like that. But we also were able to set up detectors that looked at things like the HTTP status codes. So as these various services were making REST API calls back and forth to each other, we were able to gather the information about those requests and the responses and how many of them had errors in them. And we could, within seconds, report on any service that might be reporting a high number of error responses, for example. They also had a feature that they had already implemented, which was great. Some of the more critical APIs, they actually had heartbeats that they had already set up where that particular microservice would report back a heartbeat that basically says, I'm still here, I'm still running. And so we were able to capture the information from those heartbeats and use that in a set of detectors to be able to detect if a service actually went down. So if we stopped getting heartbeats from these critical pieces of the API flow path, we would within seconds know that that had gone down because we would lose those heartbeats. You can see a diagram there on the right-hand side showing Kubernetes clusters. This is not actually from the customer itself, but a representation of that. And you can see that it shows Kubernetes clusters and the nodes and the pods and things within that. Out of the box, you'll find that with the Splunk Observability Cloud solution, a lot of times the out-of-the-box dashboards are sufficient to meet your needs. And in this particular case for this customer, we did not have to do any customization of the dashboards. We didn't have to create any new dashboards. The ones that came out of the box provided all of their needs. And again, the one that you're seeing on the right-hand side here is the Kubernetes Explorer that comes automatically when you enable the Kubernetes feature within Observability Cloud. So what were the results? The biggest benefit that they gained was time. They now are getting notified within seconds, in many cases, of either significant delays or outages, and not just to their internal APIs and microservices, but also to the third-party ones that they call. So, for example, those credit service bureaus. Now, again, we can't instrument and monitor the third-party service from within, but we can do that from an externally. By observation, we can say that we made a call to this third-party API and it took this long to come back. And did it have an error, yes or no? And so even though we can't, we don't own that service and we can't touch it, we can still have a level of observability on that API call, even though it's a third-party one. So by doing all of this, we were able to address all three pillars of observability, which Chris mentioned earlier. So we were able to gather metrics using Splunk infrastructure monitoring. We were able to gather logs using Splunk Enterprise, and we were able to grab the traces and spans using the Splunk APM solution. So what were some other benefits that they got? Another one was the visibility into their services. So the Splunk APM solution, as Chris mentioned, will automatically understand and figure out the relationships between the various APIs and who calls what, and even external providers as well as your internal services. And it generates automatically a map similar to the one that you see on the screen showing the relationships between these various APIs. And so they were able to get a visual representation of their total application end to end from the time the request comes in from the online broker, as it works its way through all of their code and all of the API calls that they have to do the scoring and all those types of things, as well as any calls to those external third-party providers. And this is something that they didn't have available to them before. We find that with many customers, when they move to microservices architectures or cloud-based architectures, very quickly that you get into a situation where there's no one person that knows the entire application end to end. It's just too big and too complex because it's got all these little micro pieces. Each piece is very understandable by a certain set of people, but it's hard to have that one person or one team that has the observability end to end. And so with Splunk APM, they're now able to get closer to what they used to have before, which is a picture of an end-to-end situation. Ultimately, of course, the driver here was really to get that significant reduction in their mean time to detect and mean time to resolve any potential problems or any outages, which of course that then translates into that increase in revenue, which of course is the ultimate goal for most businesses, is to make money. So we were able to accomplish that goal for them, and now they're able to get notified literally within seconds, if not minutes, when they have any significant problem that's affecting their ability to respond to those online brokers and ultimately snag some business from those borrowers. So let's talk how TechStream approaches an observability project or solution. And we use this methodology with the customer that I just walked you through. We call it a quick stream, and I'll talk a little bit more about the specific phases of the quick stream, but we usually start out by talking to the customer about what are your goals. Let's not talk technical stuff. These are what are your business goals. And so we ask questions like, what aspect of your business would benefit by having an observability solution in place today? What processes do you need to have that visibility into? What's the business benefit to you if you had that today? So using the example of the customer we just walked through, the business benefit to them, quite frankly, is they can make $200,000 to $300,000 an hour more than they can without observability when they have an outage. And then as we drive into those processes, what information do we need to be able to determine whether those are healthy or not? So is it just response time? Is it error rate? Is it number of requests per second? Is it utilization? Is it speed? A variety of things. So we drill down into that. We then work with the customer to put together a roadmap. And we really want to figure out how are we going to get us from point A, which is where they are today, to point B, or maybe we should call that point N. I'm not sure. But what's Nirvana look like? If we've talked about your goals and objectives, and we have talked about what would fix all of that, well, what's that Nirvana? What's that ideal solution when everything is observable and you're able to meet your goals and objectives of whether it's MTTR, MTTD, more revenue, whatever they might be? How do we get there? How do we get from point A to point B or point N? So there's a lot of technical aspects to this. Project plans are involved, of course, but we also want to consider the business. So what we found with observability in particular, although this is true of a lot of different types of projects, there tends to be a need to change the organization in some way. So it's not just putting technology into place. Just dropping Splunk Observability Cloud into the fintech lender didn't magically fix everything. It required more than that. And so we work with the organization to identify what other things need to change outside of technology. Maybe there's processes that need to change. Maybe there's people that need to change. Maybe there's organizational structure that needs to change. Maybe there's a culture that needs to change or be enhanced to support an observability culture or mindset within their organization. So we want to make sure that the organization is ready for the solution, or else the solution is going to fall flat on its face. So we then drill down into who needs to be involved. Again, not just looking at IT, but looking at other business users within the organization. These could be key stakeholders. These could be various SMEs. So we look outside of just the IT and the obvious to try to find out who else needs to be involved in this. Many cases, in today's world, we're all connected. And so what other third-party systems or vendors or partners do we need to consider? Many companies do not work in a vacuum. And as you saw with the customer example here, they make outside calls to credit service bureaus to get credit scores and other information about potential customers. And so what do we need to do to consider those? What's the implementation timeframe? Is there any particular goals and desires there? Maybe you're Amazon and you've got Prime Day coming up, and we need to have this implemented before then so that they can be able to respond and keep everything working for the increased volume that they're expecting. Or maybe it's FedEx, and you've got a holiday coming up at Christmas time, and that your delivery and shipping needs are going to double or triple come the Thanksgiving timeframe, and so we need to get something in place there. So we talk through those if there are any big drivers outside of IT that we need to be aware of. And then anything that we need to know about the specific approach to the implementation. And this is really looking at, how do we want to add observability or engineer and architect an observability solution? Are you looking to go in and instrument all of your code all at once and have, a broad brush, big bang type of an approach? Or are you interested in maybe picking a few critical pieces and instrumenting those and setting those up and making them become observable? Do you want to go and do all of your legacy code? Or maybe you only want to look at new code. So maybe you decide that, hey, from this point forward, anytime we touch code, either to write something new or to add a new feature, we're going to go ahead and take the time to then make it observable. And over time, we will eventually hopefully hit most of the code, if not all of it. And in 3 years, maybe everything will be observable. So lots of different approaches that we can take there. So to kind of summarize it up, again, we call this process our quick stream methodology. And this is something that we've proven works with many, many hundreds of customers over the last decade or so. And at a very high level, and these typically take, I'll say 2 to 3 weeks. But the goal of the quick stream process itself is not to do a complete implementation. The goal of the quick stream is to identify all of the requirements, pick a manageable subset of your application that we can do something and add value to, implement that, show you the value, show you how it's done, prove that there's value there, and prove the process, and then rinse and repeat. So again, in 15 days, we're not going to go and instrument all of your code and make all of it be observable. Well, we might if it's a very small environment. But generally, this is going to be a subset of that. So again, spread out over those 3 weeks, we'll have our kickoff call. We mentioned that where we talk about our goals and objectives. We will identify critical success criteria. So this is measurable things that we can evaluate as we're going through the quick stream, and most importantly, at the end of the quick stream, to say, were we successful? And again, if they're not measurable, it's going to be hard for us to come up with that yes or no answer. And the idea is we want to be able to show success, not just for us, but for the customer. So that the customer can then go and maybe they have to sell this within the organization that, hey, we just did the quick stream with TechStream, and we were able to implement Observability Cloud in this particular area. It was a great success. Now let's go do that throughout the rest of the organization. The second, third days, we typically will set up a trial environment or a sample environment. So something in Observability Cloud so that we've got a place to send all this data. We'll get that provisioned, get the users set up that are going to be participating in the quick stream, and verify that we've got connectivity and everything. Observability Cloud is a hosted solution. Then we move into the actual the work, if you will, and that's going in, setting up infrastructure monitoring if we're using that, setting up APM if we're using that, getting the application instrumented, installing the smart agents, so on and so forth. And that can take anywhere from a couple of days to the better part of 2 weeks, depending on how much of the piece we've chosen to do for the quick stream. We'll then work on building out, taking that data once we've got that into Observability Cloud, and what I call turning that data into useful information. So maybe we need to build some dashboards, or maybe we just need to customize some of the out-of-the-box dashboards. Maybe we need to set up alerts and or detectors, as we call them with Observability Cloud. But doing those customizations and things to make it work for you. If we've got any third-party providers that we need to integrate it with, we can do that at this point as well. We can also set up integrations with some of your other systems. So for example, maybe we set it up so that it creates a ticket in ServiceNow whenever there's a problem detected in the application. So we would set those up as well. And then we want to test and see, how did we do? Let's go back and look at those critical success criteria that we identified on day one and see, let's generate the metrics or do the evaluation to decide, hey, did we meet that one? Yes or no? Did we meet that one? Yes or no? And then finally, have a readout. Typically, this could be with your key stakeholders to walk through what was done during the quick stream, show that success, and then talk about next steps. And now I'll turn it back over to Matt to wrap us up.
Cool. Thanks, Carl. So at TechStream, our goal ultimately is to be your trusted advisor, to help guide your decisions, quickly implement the right technologies with the right people, and to keep it running for sustainable growth. And not only with Splunk, but also with AWS and Oracle. And across all of those partnerships, we're experts in software, services, support, and sourcing. And with Splunk, we're experts in the full product stack. So with Splunk, from a software perspective, we know it inside and out. We have a unique capability to provide bundling and finance options and provide incentives from a number of partners. From a services perspective, all of our consultants are Splunk certified. We have competencies across security and compliance, as well as obviously observability and IT ops. And we are partners with Splunk Professional Services as well. So known and trusted by Splunk. From a support perspective, we provide managed security, MDR, security analysis, and also general managed services, whether that's the Splunk application or the Splunk application all the way down to the infrastructure. Things like patching and vulnerability, proactive type activities, as well as reactive as directed support as well. Ways to extend your team and take load off your team and to scale your operations. And from a sourcing perspective, we can help you build your team. So whether that's finding a contract resource for the short term, or building your team, training them up, and finding folks to grow your Splunk knowledge are things we do as well. And finally, on behalf of Chris and Carl, we appreciate you investing your time today to let us talk through how to operationalize your observability strategy. If you'd like to discuss your observability goals in more detail, you can reach us via the information on the screen. And we'd like to thank you for your time, and hope you have a great rest of the day.